Have you ever really stopped to think about what happens in that split second between typing in a website, hitting enter, and a full-blown interactive page just appearing? It seriously feels like magic, but it's actually one of the most incredible, high-speed ballets in all of computing. So today, we're going to pull back the curtain on that magic. We're going to break down step by step exactly how your browser turns simple lines of code into a living, breathing web page.
So what is actually going on in there? Well, it's not just one thing, it's a whole perfectly choreographed pipeline of events. First, the browser has to build all the visuals. Then it needs to run the code that makes everything interactive. And finally, it has to manage all of that so it feels totally seamless and instant. All right, let's dive in, starting right at the beginning, building the picture.
First things first, the visuals. Before any JavaScript can do its thing, before any button can be clicked, the browser has to actually draw the page. This sequence of steps is called the critical rendering path, and it's basically the universal blueprint for turning your HTML and CSS code into actual pixels you can see on your screen.
This 5-step process you're looking at right here, parse, style, layout, paint, and composite, this is the universal language of web rendering. It doesn't matter if you're on Chrome, Firefox, or Safari, this is the core logic they all use. And that standardization, that's what makes the web work everywhere, on any device. So let's break down what each of these steps actually does.
It all kicks off with parsing. See, the browser gets these raw HTML and CSS files, but as plain text, they're not very useful. So it has to convert them into these tree-like structures that it can understand. First, you've got the DOM, the Document Object Model. You can think of this as the skeleton of the page. It represents all the content and its structure. Then it creates the CSSOM, the CSS Object Model, which represents all the styling rules, kind of like the clothes that skeleton is going to wear. So next, the browser combines those two trees. In the style step, it basically walks through the DOM's content tree, and for every single element, it finds the matching rules in the CSSOM to figure out its final computed style. You know, is this button blue? Is this text 16 pixels tall? And once it knows what everything looks like, it moves on to layout. This is where it calculates the geometry, the exact size and position of every single element, creating a final blueprint of the page.
With the blueprint ready, the browser's gotta draw. And this is a really cool two-part process. The paint step is fascinating because it doesn't actually draw pixels directly. Instead, it creates a list of drawing instructions, almost like a recipe. Draw a circle here, draw this text over here. Then the composite step takes over. It intelligently breaks the page into different layers, kind of like sheets of glass, paints them, and then assembles them into the final image. The real game changer here is that this happens on a separate thread, which is why you can scroll smoothly over a complex page while it's still loading. The browser is literally just moving a pre-painted layer around. It's so efficient.
Okay, so we've got a beautiful but static image. But modern web pages are anything but static, right? They're dynamic, they're interactive, and that interactivity is all powered by JavaScript. Inside Chrome and Node.js, the absolute beast responsible for this is the legendary V8 engine.
V8's incredible power comes from this technique called just-in-time, or JIT compilation. See, back in the old days, you basically had two choices: slow interpreters that read code line by line, or slow compilers that had to process everything up front. V8 does both. It starts interpreting the code immediately, so you get a really fast startup. But then, as the code is running, it identifies the parts that are used over and over, the hot paths, and it compiles just those parts into highly optimized machine code. This gives it speeds that are right up there with natively compiled languages like C++. It's literally what makes modern, complex web applications possible.
Here's a look at how that actually works. First, just like with HTML, the JavaScript code gets parsed into a structure called an abstract syntax tree. Then, V8's interpreter, which is called Ignition, gets things moving quickly by turning that tree into an intermediate format called bytecode. As Ignition is running this bytecode, it's also gathering feedback. It's watching for functions that get called thousands of times. When it finds one, it sends that hot bytecode over to the TurboFan compiler, which then creates a super-fast, optimized version. It's this multi-tier system that gives us the best of both worlds: fast startup and incredible peak performance.
Of course, running all this code creates a lot of temporary data in memory. To manage this without just freezing the application, V8 uses a super advanced garbage collector called Orinoco. Instead of having a long stop the world pause to clean up memory, Orinoco works in tiny iterative steps, often at the same time the code is running. So V8 is not only incredibly fast at running code, but it's also incredibly fast at cleaning up after itself. But there's still another huge challenge it has to solve.
And here we get to the big paradox at the heart of JavaScript. It's single-threaded. That means, technically, it can only do one thing at a time. So, how does it handle time-consuming tasks, like fetching data from a server without just freezing the entire page? The answer is the absolute genius of the event loop.
I mean, really, think about it. This is the central problem the event loop was designed to solve. If you click a button that needs to make a network request, you don't want the entire user interface to just lock up and become totally unresponsive while it waits for a response. The event loop is the clever mechanism that allows single-threaded JavaScript to be non-blocking.
So here's the model in action. When your code runs, each function call gets added to something called the call stack. But when it hits an async operation, like a timer or a network request, it doesn't wait. No, it hands that task off to the browser to handle in the background. Then, when the browser's finished, it places the result, the callback function, into the callback queue. And all the while, the event loop is acting like a bouncer at a club. Its only job is to ask one question over and over and over. Is the call stack empty? The very moment it is, the event loop grabs the first thing from the queue and pushes it onto the stack to run. This simple continuous loop is how JavaScript juggles dozens of tasks without ever freezing up. It's brilliant.
So this combination of the V8 engine and the event loop is incredibly powerful. But what's really interesting is that it doesn't just live in the browser. V8 is also the heart of Node.js, the super popular server-side platform. But the environment it lives in completely changes its behavior and its priorities.
In the browser, the event loop's #1 job is a smooth, responsive user interface. It has to stay in sync with that whole rendering pipeline we talked about earlier. But in Node.js, on a server, the goal is totally different. It's all about handling as many network requests and file operations as possible, as fast as humanly possible. To do this, it uses a powerful C++ library called libuv. This thing provides an event loop built from the ground up for thousands of concurrent connections. It's a whole different ballgame. Same engine, totally different playground.
Okay, so this has all been a pretty deep dive into some fascinating internal architecture. But why should you, as a developer, actually care about any of this? Well, it's because understanding how the system works allows you to work with it, not against it, to build way faster, more performant applications.
So how do you actually use this knowledge? Well, for starters, if you want buttery smooth animations, stick to animating CSS properties like transform and opacity. Why? Because the browser can handle those on that super fast compositor thread we mentioned, which means it gets to skip the expensive layout and paint steps entirely. Want your JavaScript to fly? Write predictable code that V8's TurboFan can easily optimize. And maybe most importantly, never block the event loop. A long-running synchronous task is the #1 cause of a frozen page or a slow server.
I absolutely love this quote from the V8 team because it sums up everything just perfectly. These systems are so complex and so highly optimized. Your job isn't to try and be clever and outsmart them. Instead, you just need to understand the patterns they're designed for, like stable object shapes and non-blocking code, and the engine will reward you with just amazing performance. When you think about it, from the critical rendering path that's obsessed with getting pixels on screen, to V8's JIT compiler, to the non-blocking event loop, every single piece of this architecture is designed for speed and responsiveness. The entire system is built for you to succeed. So the only question left is, how are you going to leverage that design to build the next great thing on the web?